Hello everyone, my name is Dan the Tutor. In today's video, we're going to be talking about completing the square. This is something that's going to show up in Algebra 2, pre-calculus, geometry, and it's another method of factoring, probably the most complicated method of factoring, but it has its uses in math. But before you even get to the uses, you need to know how to do it. So that's what we're going to talk about first. So let's start with a simple example. X squared minus 2x minus 8 equals 0. First of all, if you want to factor this the normal way, you already know the answer is going to be x minus 4 times x plus 2 equals 0. And then you would just put the opposites of the two factors, so x equals 4 and negative 2. So how fast did we get that? Like less than 30 seconds probably, if you know what you're doing. You're going to see that completing the square will get you the exact same answer in 10 times longer the time and 10 times harder. So then that begs the question, why do we do completing the square? There's only a few examples I could think of in math where you need to do it this way, but most of the time you can just do normal factoring. So in other words, when you have the option to avoid completing the square, you should always choose avoid completing the square. But sometimes they force you to do it, and that's why we're learning this right now. So here's what you need to do for completing the square. First, remembering from the quadratic formula here, a is going to be 1, b is going to be negative 2, it's the middle term, and c is negative 8. Now the only term we really care about is b. And the reason why is the first thing you're going to do to complete the square is you are going to add b over 2 squared, to both sides. Now let's see what that's going to look like. B over 2 is negative 2 over 2, which is negative 1. And then b over 2 squared is going to be negative 1 squared, which is just positive 1. So it looks like we're going to add 1 to both sides. So now here's what it looks like. X squared minus 2x plus 1, still minus 8 from before, and then equals positive 1. Now honestly, we want to get rid of this minus 8 too. We only want the plus 1 for completing the square. So in other words, I'm going to add 8 to both sides. And now it looks like we have x squared minus 2x plus 1 equals 9. Now we're going to factor the left side. The way you're going to factor it, and this is always going to be true, it's going to be x plus b over 2 squared. That's what the factors are going to be. Now if you remember what we said earlier, if b was negative 2, then b over 2 is negative 1, and that negative matters. It looks like the factor is going to be x minus 1 quantity squared, and on the right side it's still 9. By the way, if you don't think this is the right factors, well, you can FOIL it if you want. You're going to get right back there, and that's good because that's what we needed to happen. So in other words, this is always going to be the factor, and really the first step, that's the second step right there. The first step is add b over 2 squared to both sides. So step 1, that. Step 2, factor using this right here. Step 3, solve. How do you solve? Well, first you got to take the square root of both sides, right? And when you take the square root, don't forget it's plus or minus. So in other words, we have x minus 1, because the square root and the squared cancel. You've got x minus 1 equals plus or minus 3, which is the square root of 9. Now technically what you're supposed to do here, and I agree with this, you're supposed to say x minus 1 equals positive 3 and x minus 1 equals negative 3. In other words, we write it out in two different equations. And now you're going to solve for both. X equals, add 1 to both sides, you get x equals 4. And then you add 1 to both sides here, x equals negative 2. Is that what we said earlier at the beginning? Let's see. I think I erased it, but yes, it is the exact same thing we got at the beginning when we just factored the normal way. So that proves that completing the square works. Now let's look at a few more examples today. X squared plus 5x plus 4 equals 0. In this case, b is 5, and I'm going to start with b. So then we're going to find b over 2, which is 5 halves. That's not very friendly, but whatever, it's fine. And then b over 2 squared. You have to square both the numerator and the denominator. So it's going to be 25 over 4. And that's what you're going to add to both sides. So now when I add that to both sides, I've got x squared plus 5x plus 25 over 4 plus the 4 from earlier, which I will get rid of in the next step, equals 25 over 4. So like I said, I got to subtract 4 from both sides. This is annoying because what's 25 over 4 minus 4? Well, remember, you need a common denominator, so I'm going to multiply by 4 over 4. That will get me 25 over 4 minus 16 over 4, which ultimately leads me to 9 over 4. So that's it for the right side. On the left side of this equation, I need to factor this part right here, the x squared plus 5x plus 25 over 4. Now remember what we said earlier, it's just going to be x plus b over 2 quantity squared. B is still 5, b over 2 is 5 halves, so it's going to be x plus 5 halves squared. That equals the right side, which is 9 over 4. Looks like we're good so far. And once again, I'm going to take the square root here in order to solve for x. Again, that will be plus or minus. Now, the square root of 9/4, that's going to be square root of 9 is 3, square root of 4 is 2. If, for instance, you didn't know the square root, like let's just say hypothetically, you had square root of 10 over 13, then you'd probably just leave it like this, or you'd rationalize the denominator, which is probably a topic for another day. So I'm just going to tell you, leave it like this for today if you ever see something that doesn't reduce perfectly. So anyways, we have 3 halves, technically plus or minus 3 halves equals x plus 5 halves. Again, the square root and the squared cancel. And again, I'm going to write this out as two different things. So like x plus 5 halves equals positive 3 halves, and x plus 5 halves equals negative 3 halves. Now I just have to subtract 5 halves from both sides. Since they already have the same denominator, that's going to be easy. 3 halves minus 5 halves, that's going to be x equals negative 2 halves, which is negative 1. So x equals negative 1 is one of our solutions. Then the other one is x equals negative 3 halves minus 5 halves. That's going to be negative 8 halves, which is going to be negative 4. So that's going to be our other solution. So as you can see, two easy solutions for this one, even though it was a lot of complicated math in the middle. The next example we're going to look at is going to be a weird one. It's x squared minus 9 equals 0. You'll notice why this is weird because b is 0, which means b over 2 is 0, and b over 2 squared is also 0. So it almost looks like everything's 0 here. What do you do in this case? Well, in this case, completing the square doesn't even make sense. As a matter of fact, what you do, technically, is x squared minus 9 equals 0, add 9 to both sides, x squared equals 9, and now you're already ready to take the square root. Just take the square root of both sides, plus or minus. Looks like you get x equals plus or minus 3. And if you want to write that separately, x equals 3 comma negative 3. And that's all you have to do for that one. So in other words, this is called a difference of two squares, x squared minus 9. I don't think you'll ever see a complete the square for this one, but if you do, it's kind of impossible in a way because everything's 0. Like you'd add 0 to both sides. The factors would be x plus 0 squared. Doesn't make a whole lot of sense to do completing the square here, so you do this method instead. And once again, if you wanted to factor the old-fashioned way, you absolutely could. You'd get x plus 3 times x minus 3 as your factors, and again, you'll get the same exact answer. So I don't care which way you do it. You do whatever you prefer. Now for the last two examples, these are going to be the hardest ones. We have 2x squared minus x minus 3 equals 0. So for this one, this is not going to work. Basically, if you wanted to use the completing the square method, the formula that I just taught you a minute ago, this a has to be 1. You'll notice it's not 1. A is 2 right now. So that's a problem. So what are we going to do? We got to factor out that 2. And the best way to factor out is to divide everything by 2. So here's what it's going to look like. 2 times the quantity, x squared minus, that's 1/2 x, and then minus 3 halves equals 0. Actually, I wouldn't even recommend doing this because you already know we're going to move this 3 halves to the other side. And if you want to move the 3 halves to the other side, then you're going to have to multiply, distribute this 2 before, and that's going to be a little confusing. So let me just tell you, before you even factor out the 2, before you do that, why don't we add 3 to both sides first? So in other words, we have 2x squared minus x equals positive 3. Now let's factor out the 2 on the left side only, which is completely fine. So the left side is going to be 2 times the quantity, x squared minus 1/2 x. On the right, you just have 3. You do not have 3 halves because the 2 is not distributed on the right side. We only did it for the left. Now we will continue the problem like normal. In this case, b is now negative 1/2, which means b over 2 is going to be negative 1/4. And then b over 2 squared, remember a negative number squared is positive, it's going to be 1 over 16. That's what we're going to add to both sides now. So again, as I was alluding to earlier, I have to be careful where I add this 1 over 16. I'm adding it inside the parentheses. So in other words, the plus 1 over 16 goes right here, which means I cannot add 1 over 16 to the right side. I cannot. The reason why is because this is technically 2 over 16 because I distribute it. So instead of adding 1 over 16, I need to add 2 over 16 because I factored out that 2 on the right side. Now everything's equal. And yes, if you want, you can reduce 2 over 16 to 1 over 8. That's absolutely okay. So for the right side, 3 plus 1/8, I need a common denominator. 3 times 8 over 8 plus 1 over 8. That's going to get me 24 over 8 plus 1 over 8, which is finally 25 over 8. That's the right side. Now the left side. The left side is going to be where I factor, actually. So if I factor this, first the 2 is still out in front. Remember, it's going to be x plus b over 2 squared, or b over 2, we said earlier, was negative 1/4. So it looks like it's going to be 2 times x minus 1/4 squared, and that's what I'm going to write right here in the equation. Now, before I take the square root of both sides, I have to divide by 2 first, because that's how you solve equations. You got to get rid of the 2 before you take care of the squared. So in other words, it's x minus 1/4 squared equals 25/8 divided by 2 is the same thing as 25 over 16. And now I'm ready to take the square root of both sides, and remember it's plus or minus for the right one. So for the left side, it's just x minus 1/4 because the square root and the squared cancel. On the right, plus or minus, square root of 25 is 5, square root of 16 is 4. Amazingly, that works out. Now, last step. Take the 2 separately. So set equal to 5/4 and x minus 1/4 equals negative 5/4. And then you just have to add 1/4 to both sides. So x is going to be 5/4 plus 1/4. That's going to be 6/4, which reduces to 3 over 2. That's one answer. And then the other answer is x minus 1/4. Well, I add 1/4 to both sides. So negative 5/4 plus 1/4. That's going to be negative 4/4, which is just negative 1. And there's my other answer. Okay, I know that one was harder, but hopefully this last example that we do will finally clear everything up. It's negative 4x squared minus 7x plus 2 equals 0. Again, the first thing I'm going to do, I'm just going to move that 2 to the other side because I know I'm going to do it eventually, which leaves me with negative 4x squared minus 7x equals negative 2. Now what I need to do is I need to factor out this negative 4 so that I can get back to a equals 1. So when I factor out the negative 4, it's the same thing as dividing the left side by negative 4. So it's going to be negative 4 times the quantity x squared plus 7/4 x, because the negatives cancel. And on the right side, I still just have negative 2. Don't touch it. Okay, now b is equal to 7 over 4, which means b over 2 is 7/8. And b over 2 squared is going to be 49 over 64. That's going to be fun. But remember, it's going to be negative 4 times x squared plus 7/4 x plus 49 over 64. And now what I have to add to the right side is basically this number times negative 4. So already on the right side was negative 2. I am adding 49 over 64 times negative 4 because I had to distribute the negative 4. Now it just so happens 49 over 64 times negative 4 is going to become 49 over negative 16, or you can just say minus 49 over positive 16 instead. That works as well. The way I got that, by the way, this 4 is in the numerator, 64 is in the denominator, reduces to a 16 in the denominator and 1 in the numerator. That's how I did that. And then I need a common denominator of 16. That's going to be negative 2 times 16 over 16 minus 49 over 16, which is going to be negative 32 over 16 minus 49 over 16. Negative 32 minus 49, it's going to be negative 81 over 16, which we will be dealing with later. Then for the other side, it's going to be negative 4 times the quantity, x plus b over 2, quantity squared. So that's going to be negative 4 times x, what was b again? Plus 7/8 right there. So plus 7/8 squared, and that's what's going to go right here. Negative 4 times x plus 7/8 squared. Yeah, I do realize this is really, really complicated and really annoying, but hopefully it was making sense up until this point. And if not, still doesn't make sense, just post in the comments below, and I'll answer your questions. So again, here I need to divide both sides by negative 4 in order to get the x plus 7/8 squared by itself. Now, negative 81 over 16 divided by 4 is the same thing as this, just multiplying by negative 1/4, which basically means we're going to have negative 81 over negative 64, and yes, the negatives kind of just go away now. And on the left, we still have this, x plus 7/8 squared. So now I'm going to take the square root of both sides, and again, when I take the square root, it's plus or minus, and so the square root and the squared cancel, leaving me with x plus 7/8. On the right side, I have plus or minus, square root of 81 is 9, square root of 64 is 8. And so now we're very close. X plus 7/8 equals 9 over 8, and we have x plus 7/8 equals negative 9 over 8. Again, you break apart the two equations. So now I need to subtract 7/8 from both sides. X is going to be 9/8 minus 7/8 is 2/8, which does reduce to 1/4. So that's one answer, 1/4. And then the other answer is minus 7/8 from both sides here. It's going to be negative 9 minus 7 is negative 16 over 8. And that's going to reduce to negative 2. There. Beautiful answer for that one. So that's going to do it for completing the square. Hopefully that made sense. I know this was a long video, but I know it's a complicated topic, so I wanted to do a bunch of example problems. If you do have any comments or questions, please post them below. I hope you have a great rest of your day, and I'll see you in the next video. Bye-bye.